So we can solve systems equations on the graphs, and where the solution occurs is where the two graphs will intersect. So for a problem like this, we need to come up with the relationships, and once we come up with the relationship, we can find the solution by graphing the solution. So in this case here, software A costs $600 for the license plus $150 for each computer installed on. Software B has a flat fee of $180 per computer. So for what number of computers is it beneficial to buy software A? So first of all, we have to establish our variables. Okay, so in this case here, it looks like the ratio of that we're talking about, or the slope, can give us a good indication of the y and x. So this is dollars per computer. So it looks like dollars is our dependent variable, and the number of computers is our independent variable. So I'm going to let x equal the number of computers, and then y equals the charge or the cost. So we're going to need to come up with two relationships. So the first relationship we'll do for software A. So the total amount is equal to $600 plus $150 per each computer. Okay, so the $150 represents our slope. So that's software A. For software B, we have a flat fee of the cost is $180 per computer, so times the number of computers. So there's our two relationships. If we graph these, we end up with, I'm going to put them into y equals form, so mx plus b. For the second equation, it's going to be y equals just mx, b is equal to 0, and we can then graph to see the solutions here. Okay, so I'm going to graph this, let's make maybe negative 10 to 40, and negative 1,000 to 5,000. Okay, so you may need to play around this, but I kind of know how many computers we're talking about and how much money, so I've been able to kind of do that, figure that out beforehand. And as I graph this, my first equation is going to be $600 with a low slope kind of going up like that, and the other one is going to be from 0, it's going to go up kind of in this way, and we have an intersection point that's going to represent our solution. So from the graph, we could solve this algebraically, but from the graph, the intersection point that we're getting is 20 computers and $3,600. Okay, so in this case here, once we hit 20 computers, software A, which is a blue line, is going to be cheaper. So for greater than 20 computers, software A is a better deal. Okay, so we can find the solution here, and then we still have to analyze the problem. We're still finding out where the software A is better. The software A is going to be better after 20 computers because it's cheaper per computer.